So this is the last part of the chapter on waves. Sorry about the ding. The source of energy from the waves is of great interest because fossil fuel and greenhouse gases are a great concern now. So we're looking for renewable energy, and waves are always there. So if we can harness this energy, like wind energy or solar energy, would be great, right? So considering the ocean is constantly integrating the winds that are blowing all the time, with seasonal differences nonetheless every day. And even though only 2% of the energy is being harvested by the ocean, that energy is integrated and a lot of waves are coming close to the coast. And wave energy is proportional to the wave height squared. We can easily start to see how much potential energy can be harvested from waves, right? Anything you put in the ocean, obviously, you have to worry about how to protect them from large storm waves. So you're trying to harvest wave energy, but if this large storm wave comes in, can destroy not only offshore drills and so on, but also the power plant itself. And waves are intermittent like winds. Sun is not either a perpetual or a constant source of energy. Clouds, nighttime, and so on make them intermittent sources, right? So how to produce power consistently, that's always an issue. Plus there are environmental issues like building power plants close to the shore. You can affect the flow of sand and water. You can affect wave breaking and coastal erosion, and you can also affect sediment flow and interfering with the ecology of the region as well. And remember, anything we put in the water is going to be growing biology in it, and we're going to have biofouling. This problem is always very big for anything we put in the ocean. So here is a example of one of the ways that the energy can be harvested. So waves are coming in. You have a stabilized cliff here, and there is a kind of a chamber in which there is a turbine, and a turbine is attached to a energy generator, right? So anything that can make the turbine rotate is going to produce energy by using the processes that you have learned about, probably the dynamo effect and so on. So as the wave comes in, hits the cliff and goes up, it's going to compress the energy that's in there, and the air is going to try to go out through the generator. So the turbine is going to rotate, and the trick here is to make the turbine operate in both directions, because once the wave comes in, compresses the air and pushes it out, more air is going to come back into the low pressure region in this chamber through the generator, and that also is made to rotate the turbine, so the turbine can generate energy in both directions. Seems very simple, and there are operating plants around the place. The first commercial wave power plant began fairly recently, a couple of decades ago in 2000. It's called Limpet, Land Installed Marine Powered Energy Transformer. It's off the coast of Scotland, which is one of the more choppy, wavy regions. So if you have a beach that's not fun and always very stormy and wavy, then it's good for wave energy production. There you go. Something good comes out of it, right? So it produces about 500 kilowatts of power under peak operating capacity, and you have to look at average consumption. An Indian household consumes something like 25 kilowatt hours per month. So you have to take kilowatts. Kilowatts is the amount of energy installed capacity of the power plant. Kilowatt hour is the amount it will produce per hour. So if you run it for a month, then you have to multiply the kilowatt hour by the number of hours in a month and so on. So these are kind of simple calculations, but you should be aware of how to take installed capacity and demand in kilowatt hours per household or an industry or something else, and then see how many households can be run by it, etc., etc. The other form of extracting energy is this kind of a floating device which has chambers in them, and it kind of got oscillates, so it got modules, and it goes up and down with the wave, and I think some kind of a hydraulic fluid gets moved when it goes up and down, and it generates power. So it's, I think, off of Portugal, installed in 2008, generates about it has about 50 wave power plants. There are about 50 such plants around the world globally. I think it produces a tiny amount of power, but nonetheless they can add up if you install a lot of them around the world. And how would you install them? You want to estimate how much wave power is actually available. So you can see these are the regions. Again, tropics fairly mild. We had seen southwesterly winds over the Indian Ocean have high wave heights, so there is some energy there. The wave energy in terms of kilowatts per height of wave is shown here. So 0 to 15, 15 to 30, and so on, and over 60 in the red areas. You see very few red areas here in South Africa, where we said rogue waves get created because of the circumpolar current and the Agulhas current meeting each other and exploding and so on. Tip of South America, some island here, New Zealand, Australia, and of course the stormy region here in the North Pacific. Okay, these are kind of the global wave energy resources. Again, constructing a properly protected wave generation system and transmitting the energy from the middle of the ocean to land and so on. The cost of building such a thing and the return of investment and so on are all great calculations that experts make. Nonetheless, waves provide a good source of energy, and they will be continued to be harvested more and more for renewable energy, because we have to reduce our carbon emission, right? Right.